All right, so this is the first lesson on factoring polynomials. There's going to be 3 lessons in the next 3 days over factoring polynomials. This is something we're going to be using a lot the remainder of the year and something you're going to be using a ton in Algebra 2 and beyond. So very, very important to get a good understanding of this. Okay, so what we're going to be doing before we start actually factoring polynomials, we need to review factor trees, okay? You saw factor trees in earlier grades. Just want to give you a short review on how they work. So the whole point of a factor tree is we're finding the greatest common factor, the GCF of 2, in this case, whole numbers, all right? So if I build a factor tree for 12, we're separating 12 into its factors. Factors meaning things I can multiply to get 12. So one way to get 12 is 1 times 12, okay? Now, 1 I can't factor any further, of course, because the only way to get 1 is 1 times 1, so I'm going to leave that. 12 I can do 6 times 2, all right? And sure, I can do 4 times 3 as well, but it doesn't matter. You're going to get the same result whether you do 6 times 2 or 4 times 3. Okay, 2, and by the way, the 1 I'm going to circle because I can't go any further with it. This 2 I can't go any further with because the only way to make 2 is 2 times 1. 2 is a prime number, right? So I'm going to circle that. The 6 I can make from 3 times 2, okay? And both 3 and 2 are primes as well, so I'm going to circle those. Okay. We did a factor tree for 12. Now we're going to do one for 20. Let's do this up here so we have more room. So 20, I'm going to go 1 times 20. 1 is a prime. 20, I'm going to go 10 times 2. All right. 2 is a prime. I'm going to circle that. 10 is 5 and 2. Both of those are primes. And we're done. We can't go any further. Now, to find the GCF, we're looking for what they have in common in terms of what we circled. Okay, they both have a 1 in common, but we're not going to count the 1. Okay, 1 we ignore. Okay, the 12 has a 3. The 20 does not, so we'll ignore that 3. The 20 has a 5, but the 12 does not. We'll ignore that 5. What they have in common is 1, 2, 2 2s. So the GCF is 2 times 2, which is 4. Okay, so the greatest common factor that's common to both 12 and 20 is 4. Notice we can make 12 from 4 times 3, and we can make 20 from 4 times 5. So the greatest factor that they have in common is that 4. Okay, I'm going to do some erasing because I probably didn't leave enough room to do the next one over here, but that's all right. You hopefully already got this. Okay, let's do 24 and 36. So 24, 1 times 24. 1 will ignore. 24, I'm going to go 6 and 4. Okay, neither of those are primes. 6 is 3 and 2. Those are each primes. 4 is 2 and 2. Those are each primes. 36. 1, 36. 1 will ignore. 36, I'm going to do 6 and 6. Okay, no primes yet. 6 is 3 and 2, and we have another one of those. Okay? Oh, I forgot to circle this 2 over here. Okay, so 3 and 2 are each primes. Okay, what do they have in common? Well, they have a 3. They share this 2. And they share another 2. So the GCF is they share the 3, and they share 2, 2. So the GCF is 3 times 2 times 2, which is 12. Okay, so let's apply this sort of logic to polynomials with algebraic expressions. So find the greatest common factor of 8a and 7a cubed. All right, so what we're going to do, we're going to start with making a factor tree for 8a. Okay, I can make 8a with 8 and a. All right, a is a prime because the only way to make a is a times 1. I'm going to circle a. 8 is not a prime. We can go further with that. 4 and 2. I'm going to circle that 2. And that 4 is 2 and 2. I'll circle each of those 2's. Okay, 7a cubed. You can go 7 times a cubed. All right, 7 is a prime number. A cubed is not a prime because we can break it down into a times a times a, right? Using that product rule of exponents, I'm going to circle each of those a's because those are all primes. Okay, what do they have in common? Well, the 7a cubed has a 7, the 8a does not, so the 7's not going to be in common. The 8a has a bunch of 2's. The 7a cubed does not have any 2's. So all that they have in common is an a. So the GCF is just a. All right, greatest common factor of 12n cubed and 16n. So let's do a factor tree for 12n cubed. That's going to be 12 times n cubed. 12 is 4 and 3. 3 is a prime. 4 is 2 and 2. Those are primes. N cubed is n, n, n. Those are each primes. All right, so let's do 16n. Actually, I'm going to leave a little more room. Okay, that's going to be 16 times n. N is a prime. 16, 4 and 4. 2, 2, 2, 2. And all 4 2's are primes. All right, let's see what they have in common. So they share 1n. And how many 2's do they share? They share 1, 2, 2 2's. So the GCF is going to be 2 times n, which is 4n. Okay, now we're going to find the greatest common factor of 3 expressions. 63y to the 5th. Better leave more. Hopefully I left enough room over here. Let's go up here. 63y to the 5th. That's going to be 63 times y to the 5th. All right, that's 9 times 7. 7's a prime. 3, 3. Those are each primes. And then we got y, 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 and one more y. Okay, then let's do 45y to the 4th. 45, y to the 4th. 9, 5. 5's a prime. 3, 3. Those are each primes. And then we got 4 y's. All right, now we need 27y squared. 9, 3. 3's a prime. And we got 2 more 3's over here. And then we've got y and y. Those are each primes. Okay, let's see what they all have in common. So they each have 2 3s, okay, we can take out 2 3s from each of them, okay? So the GCF is 3 times 3, and they have more things in common. They each have, I can take out 2 y's from here, I can take out another 2 from here, and I can take out another 2 from here. So they have 2 y's in common. 3 times y is 9y squared. That's your GCF. Okay, now we're actually going to use GCFs. We're going to apply it to factor a polynomial. So when factoring a polynomial that has a GCF, and not all do, this is just a special case where the GCF exists. Most of the time you don't have a GCF, sometimes you do. So when factoring a polynomial that has a GCF, we're really using the distributive property in reverse to rebuild the polynomial. Okay, let's take a look at examples so that'll make some sense. First, we need to find the GCF of 8a and negative 6a squared. So let's find the GCF. Okay, so 8a is 8 times a, and a is a prime, 4 times 2, 2 is a prime, and then we get 2 2's from the 4. All right, so negative 6a squared. So negative 6 is negative 3 times 2. Negative 3 is a prime, 2 is a prime, and then a and a, those are both primes. So what they have in common is they have a 2 in common, and they have an a in common. So the GCF is 2a. All right, so what I'm going to do is I'm going to take that GCF, 2a, I'm going to open up a set of parentheses, okay? So we want to rebuild that polynomial using distributive property in reverse, backwards. So 2a times what makes 8a? Well, 2a times 4, we already have that a. We need an 8 from the 2. We need an 8, so we need a 4 in there, okay? And then we have to ask 2a times what makes negative 6a squared. Okay, so for the whole numbers, the coefficients, 2 times what makes negative 6? That's going to be negative 3. And then we have an a. We need an a squared, so we need an a in there, okay? So this is the factorization of 8a minus 6a squared. How can you check? Well, multiply back out. 2a times 4 is 8a. 2a times negative 3a, negative 6a squared. All right, let's do a little bit of erasing. And we'll go on to the next one. All right, so we're going to factor 25n cubed minus 15n squared. Let's get that GCF, of course. Okay, and as you gain experience with this, you're not going to need to write out the factor trees. Okay, if you need to write them out, that's fine. If not, that's also fine. All right, so the GCF for 25n cubed, that's going to be 25 times n cubed, 5 times 5, those are each primes, and then we've got 3 n's, those are each primes. All right, then we have negative 15n squared, that's going to be negative 15 times n squared, negative 5 times 3. Okay. Now, what you can do when you have a negative number, and I should have mentioned this before, I can actually factor this again. Well, let's put a 3 around let's put a circle around the prime for 3. I can say negative 5 is really negative 1 times 5, okay? Otherwise, we're going to miss the 5s that they have in common, okay? And then n squared is n, and then those are each primes. So what they have in common, they have 1 5, and they have 1 n, 2 n's. So the GCF is 5 times n, which is 5n squared. Okay, so now let's rebuild this by using the GCF. So we're going to put the GCF in front of the parentheses. Okay. 5n squared times what gives you 25n cubed? Well, 5 times 5 will give us the 25. And then from n squared, we need an n cubed, so we need one more n. Okay. Then, to make the next term the negative 15n squared, 5 times negative 3 is going to give us the negative 15. And n squared, we already have an n squared over here. We need an n squared, so we're not going to do anything. Okay, so we can actually push in these parentheses a little bit. Okay, that's your answer. If you multiply back out, 5n squared times 5n is 25n cubed. And then 5n squared times negative 3 is negative 15n squared, which is what we started with. Okay, again, that's a good way to check. All right, last one is we're going to do one with multiple variables, but it's same deal, really nothing different here. Okay, so let's make a factor tree for each term. So 28u cubed b to the 5th, x to the 8th. Okay, so it's going to be 28 u cubed b to the 5th, x to the 8th. So that's going to be 7, 4, 7's a prime, 2, and 2. Those are each primes. So we got u, and we've got v, 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 and then 1, 2, 3, 4, 5, 6, 7, 8 x's. All right, and then we have negative 24 u to the 6th, v to the 9th. It's going to be negative 24 u, v, 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 v. 1, 2, 3, 4 more v's. Okay. And then these are each primes. We got to circle these over here. This is a lot of circling. And it's not really necessary if you get the hang of a factor tree. Okay, I'm just doing it to be consistent. All right, then negative 24 is not a prime, of course, so we're going to go negative 12 times 2. And then 2 is a prime, negative 4, 3, 3 is a prime, negative 2, 2, 2 is a prime, and then I'm running out of space. Let's continue over here. Sorry, iPad trouble. Okay. Going to won't this thing erase? Oh, okay. I can do the -4 over here. Okay, -2, 2 is a prime. I'm going to go -1 and 2. Those are both primes. Remember, if you have a negative, write it as -1 times whatever. Okay, let's see what they have in common. All right, this has a 7. The 28 has a 7. The bottom one does not. They have two 2s in common. Okay. Actually, they have, oh. Yeah, they have two 2s in common. Okay, let's see what they have in common for the u's. They have 1 u, 2 u's, 3 u's. So the GCF is 2 times 2. Okay. Sorry. Then we said they had 3 u's in common. And then for the v's, they have 1, 2, 3, 4, 5. Okay. And notice they don't have any x's in common because the first term has x's, but the second one does not. So the GCF is going to be 4u cubed v to the 5th. Okay, let's erase this mess of a factor tree. And again, you don't need to use factor trees if you can see the GCF without writing them out. When I do this, okay, I know that the greatest number that 28 and 4 have in common, the 28 and 24 have in common is 4. I know that u cubed and u to the 6th have 3 u's in common, or u to the 3rd. I know that v to the 5th and v to the 9th have 5 v's in common, all right? And the first term has x's, the second term does not have x's, so it doesn't have any x's in common. So that's how I get the GCF when I'm doing this in my head, okay? All right, so to factor this, we're going to take the GCF, the 4u cubed v to the 5th, and use that to remake the polynomial. Okay, from 4 we need 28, so that's going to give 7. U cubed, we need a u cubed, so we don't need to do anything. V to the 5th, we need a v to the 5th, don't need to do anything. We need that x to the 8th, so we need to add that x to the 8th into the first term. Okay, for the second term, 4 to -24, we need a -6. U cubed to u to the 6th, we need a u cubed. V to the 5th to v to the 9th, we need a v to the 4th.